Quiz limits and continuity. Number 1. Find limit these functions as x approaches 3. The first thing, substitute here. 9 minus 12 plus 3. Direct substitute. 3 minus 3 is equal to 0 over 0. This one is indeterminate form. And for poly, this is polynomial. And over polynomial. Over polynomial. And x approaches a number value, you have to factorize and simplify. Okay, try to factorize. Limit as x approaches 3. Right? X minus 3, x minus 1. Okay. X minus 3. This one cancel. So, then is equal to limit x approaches 3 negative x minus 1. Then substitute 3 negative 3 minus 1 equal to negative. So the answer is negative 2. Okay, settle. Number 2, find limit this function as x approaches 0. First step, direct substitute. Okay, and set 9 minus 0 minus 3 over 0. 0 of 9 is 3. 3 minus 3, 0 over 0. This is considered also indeterminate form. When x approaches a value, and this is indeterminate form, and this one is third, and over poly, third over poly, or poly over third, you have to multiply with the conjugate, this conjugate. Okay, let's try. Limit square root of 9 minus x minus 3 over x as x approaches 0, and the conjugate is square root of or set 9 minus x plus, conjugate is plus, set 9 minus x plus 3, then multiply, simplify. Okay, this one is, you still need to write limit as x approaches 0, multiply this one. Okay, and then you get rid of set because of multiply. Set 9 minus x times set 9 minus x, and answer is 9 minus x minus 3 times 3, 9. Okay, over this one just rewrite 9 minus x plus 3. Simplify. Limit, this one can be cancelled. Negative x. This one also can be cancelled. Okay, right, cancel. Okay, this one can be cancelled. So, and I get negative 1 over third 9 minus x plus 3 as x approaches 0. And the next step, substitute 0. Okay, here. Substitute 0, negative 1, set 9 minus 0 plus 3. Negative 1 over set square root of 9 is equal to 3 plus 3. And then the answer is negative 1 over 6. The answer is negative 1 over 6 here. Okay, settle for number 2. Number 3. What is the limit of the function as x approaches 1 from right? X approaches 1, this is 1. Okay, from right. Okay, here from right. 1. Okay, 1 from right, here left. So right here, There is no graph here, so we turn down. This is the graph here. So when x approaches 1 from right, okay, the graph is approaches negative 2. So answer is negative 2. The answer. Okay. And then number 4. Find limit, determine limit this function as x approaches 3. So first thing, substitute 3 squared 9 minus 15 plus 6 over 9 minus, this is 18 plus 9, so 0 over 0. Direct substitute and get indeterminate form. And check, oh, this is polynomial over polynomial. Polynomial over polynomial. And this is x approaches value. When polynomial over polynomial and x approaches value, you have to factorize. Okay, let's do this one. Limit x, okay, this one first. And factorize. X minus 2, x minus 3, so that you get this one, the first one, numerator, over x minus 3 square of x minus 3. Okay, then this one can be cancelled. Okay, settle. And write this one, limit x minus 2 over x minus 3 as x approaches 3. Then substitute. That was substitute at 3 minus 2 over 3 minus 3, then 1 over 0. This is infinity. Okay, so and when infinity, you have to check. This is x approaches 3. Check whether on the left and on the right. Okay, let's do on the left and the right separately. Okay, find limit. This one, this function, x minus 2 over x minus 3 as x approaches 3 from left. Substitute 3 minus 2, 3 from left minus 3. So according the number line, this number line, 3, 2, 4. 3 on the left here, on the right, means that the value is 2.999. Here the value is less than 3. So less than 3 minus 3. So the answer is should be 1 over 0 negative or negative infinity. Okay, let's do for on the right hand side. When x approaches 3 from right, x minus 2 over x minus 3. Then from right is 3.001. So 3 minus 2 over 3 right minus 3. This is more than 3. So minus 3 is equal to 1 over 0 on the right hand side. So positive infinity. So we can conclude that limit fx as x approaches 3 from left is not equal to limit fx as x approaches 3 from right. So we can conclude that limit fx as x approaches 3 does not exist. Okay, does not exist. Here, this is does not exist. Why? Because of limit on the left is not equal limit on the right. This one, determine limit. First, substitute. Okay, 7 minus 7 over 7 minus 7. So 0 over 0 is indeterminate form. You have to define the value of x. This one, 7 minus x. 7 minus x. Define. Positive, negative, and define. Or just do number line. 7. Okay, since 7 minus x So to the left is function positive 7 minus x. To the right is negative 7 minus x. This is to the left, to the right. Okay, so we need to find limit to both sides. Okay, limit x approaches 7 from left. So absolute value. Okay, this one change to take plus positive 7 minus x. So okay, simplify, get 1. Then this is constant, answer is 1. When limit x approaches 7 from right, okay, the absolute value change to negative 7 minus x over 7 minus x. So this one is limit x approaches 7 from right, so the negative 1 or negative 1. Okay, since limit fx as approaches 7 from left is not equal to limit fx as approaches 7 from right. Therefore, limit x approaches 7 for this function does not exist. Why? Because of on the left is not equal to on the right. Okay, go to number 6. Number 6, find limit this function as approaches negative 8 from right. Okay, first step, substitute 1 over negative 8 from right plus 8 to 1 over 0. Let's check. Okay, this is negative 8, negative 7, 0 here, 0, negative 9. So negative 8 from right is right. So the number is less than negative 8, 7, negative 7.999. So negative 7.99 less than negative 8 plus 8 means that this one bigger than this. So we get positive, 0 positive. So that is infinity or 0. Answer is positive infinity. Okay. Answer. Number 7, find the limit this function as approaches negative 5. Okay, substitute 10 over negative 5 plus 5 and is equal to 10 over 0 and infinity. We're going to check whether it tends to negative infinity or positive infinity. Check this one on the left and on the right. Negative 5 from left or negative 5 from right. Okay, let's do limit 10 over x minus 5 as x approaches negative 5 from left. Substitute and negative 5 for this one from right. Okay, from right plus 5. So 10 over 0 confirm. Then check the number 9. Here is 0 here. Negative 4, negative 5, negative 6. From left, from right. So negative 5 here from right. So negative 5 from right here. This is around negative 4.999. So this one less than 5. Negative 4.99 less than 5 plus 5 is equal to positive. So answer is infinity to positive. And then when limit 10 over x plus 5 as approaches negative 5 from left, and substitute negative 5 from left plus 5. Also get 10 over 0. This is negative 5 from left, negative 5.001. So this one is more than negative 5, negative 5.111. So the plus 5 means that the 0 is negative side. So it's equal to negative infinity. Then you can conclude that since limit f(x) as x approaches negative 5 on the left is not equal limit f(x) as x approaches negative 5 from right, therefore limit f(x) as x approaches negative 5 does not exist or does not exist. Here is the answer, does not exist. Number 8, find the limit of this one. First substitute and negative 1 from right. Negative 1 squared, 1 minus 1 over 1 minus 5 plus 4 is equal to 0 over 0. This is called indeterminate form. And here, this is poly over poly. Polynomial over polynomial. X approaches value negative 1 from right. So we need to factorize. So since this one is poly, factorize on the up here numerator and denominator. Okay, let's do this one. Limit x minus 1, x plus 1 over x plus 1, x plus 4. As x approaches negative 1 from right. Check x4, 5. Okay, this one okay. So this one equal, can be cancelled. And then limit x minus 1 over x plus 4 as x approaches negative 1 from right. Then substitute the next step. Negative 1 minus 1 over negative 1 plus 4. So negative 2 over 3. The answer is negative 2 over 3. And this is the answer. Number 9, find limit this function as x tends to infinity. Infinity squared infinity over infinity. This one consider indeterminate form. Okay, for poly, this is poly, polynomial, 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 polynomial. When poly or poly, when x tends to infinity, we have to divide with highest power of denominator. This is the highest power here, x squared. We have to divide every term by x squared. So, limit, negative x squared over x squared plus 9 as x tends to infinity, divide by x squared over x squared. Simplify. Limit 1 over 1 plus 9 over x squared as x tends to infinity. Then substitute 1 over 1 plus 9 over infinity is 0. So negative 1 over 1 or negative 1. The answer is negative 1. Here. Okay. Number 10. Find limit when x tends to positive infinity. for this function. So, want to find limit square root of x squared plus 4x minus x as x approaches positive infinity. Okay, first step, direct substitute. This square root substitute positive infinity, you get infinity minus infinity. This case also consider indeterminate form. For this one, you have to do something. So, since this one is in this form, one line here, you have to multiply the conjugate. It's conjugate. Okay. Limit square root of x squared plus 4x minus x as x tends to positive infinity. Conjugate. Conjugate is square root of x squared or plus 4x, or can call set plus x over set x squared plus 4x plus x. Then simplify and limit this one, expand, and then the answer is x squared plus 4x minus x squared over set x squared plus 4x plus x as x tends to positive infinity. So continue up here. Okay, simplify. Here is limit. Okay, this one cancel. 4x over third x squared plus 4x plus x as x tends to positive infinity. Okay, just copy this one and simplify. Okay. Then substitute value for infinity. There is infinity over infinity. Infinity over infinity. Still, this one under indeterminate form. Instead, you need to do something and check. Oh, this is poly over set. Okay, polynomial over set. And x tends to infinity. In this case, for poly part, you have to divide with the x. And for set, you have to divide by set x squared. Okay. Go to limit for x squared plus 4x plus x as x approaches positive infinity. Divide by x for poly, divide by x for poly, and set x squared positive. Why? Because this one positive. Okay. Simplify. Limit for x over x cancel. And here is just like x squared over x squared 1 plus 4x over x squared 4 over x plus 1 as x tends to positive infinity. Then is equal to substitute 4 over 1 plus 0 plus 1, or 4 over 1 plus 1, 2, is equal to 2. The answer is 2. Let me check the answer. Okay, here is the answer. Settle for number 10. Let's continue number 11. Find the vertical asymptotes, any, of the graph of the function. this is the function 3x over x squared plus 9. To find the asymptote, vertical asymptote, we need to find domain of this function. The domain is, this one is ratio. Okay, ratio. So take this one, denominator, ratio, denominator x squared plus 9 not equal to 0. If denominator is equal to 0, the function is undefined. When undefined, means the function has vertical asymptote. Okay, and x squared, okay, not equal to -9. This is complex number. So actually, x is real numbers. X is real numbers. So every single x is defined for the function. So let's say if you do number line to the positive infinity to the negative infinity, means here no x is excluded. All x, okay, are considered inside the domain. So we can conclude that no vertical asymptote. The answer is none. Okay, proceed to number 12. Which of the following best describes the continuity at x is equal to 5? So, to check the continuity, you have to satisfy the 3 conditions. First is, okay, the function substitute h5 in the function. F plus 5 plus 4 over 5 squared minus 2, 5 minus 35, and 9 over, this one is 10. Okay, 25, so negative 20. So it's negative 9 over 20. And then let's find the limit. Okay, the limit when x approaches 5 on the left and also on the right. Okay, second is find limit x plus 4. Okay, and then this one substitute. Okay, write the function first. As x approaches 5 from left, let's say if you want to factorize x plus 4, x minus 7, x plus 5. As x approaches 5 from left. Okay, here is 35. Okay, then substitute 5 plus 4 over 5 minus 7, negative 2. 5 plus 5, 10. So the answer is negative 9 over 20. Then when you substitute on the right hand side, this is actually just substitute. Okay, this one, x plus 4, x minus 7, x plus 5, x approaches 5 from right, and 5 plus 4 over negative 2, 10 equal same, is equal to negative 9 over 20. Okay, and conclude. Therefore, limit hx as x approaches 5 is equal to negative 9 over 20. And the third step, okay, number 2 is equal to number 1. Limit hx as x approaches 5 is equal to h5 is equal to negative 9 over 20. Therefore, h is continuous at x is equal to 5. So let's say here for this question, okay, describe continuity. So means that h is continuous at x is equal to 5. The answer is continuous. Number 13, thus the following function is continuous at x is equal to 0. This is given piecewise function. For this one, it's better for you to change to number line. So we discuss here, this is domain, okay, 0. When x is equal or less than 0, the function is negative x over 2 minus 7 over 2. When x more than 0, the function is quadratic. Negative x squared plus 2x minus 2. Then we're going to discuss the continuity on the left, on the right. Okay. So first step, find f of 0. Is it defined or not? So f of 0, 0 here lies in the function. So negative 0 over 2, choose this one. Okay. And minus 7 over 2 is equal to negative 7 over 2. Then the second is find limit. Limit as x approaches 0 from left. Left here. And same function, take this one, negative x over 2 minus 7 over 2, substitute 0 minus 7 over 2 is equal to negative 7 over 2. Okay, still equal value, so continue. Okay, substitute when here, limit x approaches 0 from right, here right, choose this function, negative x squared plus 2x minus 2, and then substitute 0 plus 0 minus 2 is equal to negative 2. Okay, check. This one is equal value, but this one is not equal. There we can conclude actually this one, limit fx as x approaches 0 from left is not equal to limit fx as x approaches 0 from right. Therefore, limit fx as approaches 0 does not exist. And okay, so the third step is just conclude. No need to show this, just conclude. Therefore, f is not continuous at x is equal to 0. Just conclude, okay, without showing the third step, okay? Not continuous. Number 14, find the value that will make the following continuous. So, as usual, change piecewise to number line. So we're talking about this one, negative 1 to the left included. Okay, the function is x squared plus c. To the right, exclude. Okay, x cubed plus 1. Then we're going to discuss negative 1 from left and from right. Okay, and first, continuity, first step, when f of negative 1, this is first step, substitute on the function itself. If this one defined, and make sure continue to the second step. Okay, negative 1 lies here, and this one is then circle. We choose the function squared plus c, so negative 1 squared is equal to 1 plus c. And the second step, find limit. Limit as x approaches negative 1. So let's say to find c, and then the function is continuous, so just take the opposite one. Here is we choose this function, the other one is we need to choose this one. So talking about -1 from right, okay, from right, choose this function x cubed plus 1, then substitute -1 cubed plus 1 is equal to 0. -1 plus 1, 0. Let's say if you want to take this, -1, okay, from left, here, take the same function, then substitute 1 plus c. This one equal with this one. So actually, this one not working. That's why we will choose the first step is this one, the function itself at the point, and the second is choose the opposite function. This one already taken, and the second is choose the other one. And the next step continue. Okay, number 2 equals number 1 when f continuous. Okay, so limit fx as approaches -1 from right is equal to f -1. So this one is equal to this. So 1 plus c is equal to 0. Therefore, c is equal to -1. Okay, so the answer is -1. Okay. Number 15. Find the value of c which would make the function continuous at x is equal to 3. And transfer to number 9. Okay. Here is all numbers, real numbers, except 3. Okay. From negative infinity. The function is x squared minus 2x minus 3 over x squared minus 9. Here also same function. Okay. X squared minus 9. Then, when x is equal to 3, the value is c. Okay. 3, this is x, this is y. Y is equal to c. This one just 1 point. Okay. Then now, this is on the left from right. Okay. First, follow the 3 steps. First step, f of 3. F of 3, just this point. The answer is c, given c. And the second step is find limit. Okay, limit x approaches 3. Since this function on the left and this function on the right equal, you just write x approaches 3. Okay, x squared 2x minus 3 over x squared minus 9. You have to take from left or from right because of this one same function. Substitute. Okay, 9 minus 6 minus 3, direct substitute. Okay, 9 minus 9 is equal to 0 over 0. This is considered indeterminate form. Then this is polynomial over polynomial. So for polynomial over polynomial and x approaches value, we have to factorize. Okay, factorize. Okay, x minus 3 x plus 1 over x minus 3 x plus 3. Then continue here. Then can be cancelled. The next step, limit x plus 1 over x plus 3 as x approaches 3. Substitute 3 plus 1 over 3 plus 3 is equal to 4 over 6, 2 over 3. So since this function is continuous, f continuous, it implies that number 2 is equal to number 1. This number 2 is equal to number 1. Okay, limit fx as approaches 3 is equal to f of 3. So this one is equal to c, and this one is equal to 2 over 3. Therefore, c is equal to 2 over 3. Answer is 2 over 3. Done.